Okay, yeah, so how many people are we? 19, not bad. So welcome everybody. Today we want to try it in Zoom to have it more interactive because with StreamYard, the software we used last time to stream over YouTube, we have to manually lift you into the stage, but here you can just talk if you have questions. So yeah, welcome to the second episode of Advanced TypeScript Trickery. And today we again have a bunch of people already prepared who want to share some awesome TypeScript tricks or trickery with us. But also in general, we are always still open for people to spontaneously appear on the stage, so to say, and share something interesting. Can just be like a 5-minute trick, doesn't have to be like a polished presentation or anything. Anything that you're excited about is awesome. So yeah, let's start. So we have already a couple of people, so to say, on the stage. Here it's not as in the previous episode where we are a bunch of people on the stage, but still. So whom we already have here, whom I know, is Simon Knott. He has been here last time in our last meetup. So Simon, the author of the founder of Query and working on SuperJSON, Blitz, and all kinds of awesome stuff. We have Pierre Antoine here, who is author of TS Toolbelt. So he's also very advanced in his TypeScript and will also later share something. The same for Simon. Simon will also share something. And then we have Emile Fougelin, or also known as Sitten, for the people who know him on GitHub. He is one of our smartest and most active community members of the Prisma community, and he's also working on his own startup called Graphmetrics. So welcome everybody, and thanks for coming. More people are coming, so if you miss anything, no problem. We are recording this and we'll also upload this. I would say we just start with Simon. Simon, how are you doing?
I'm fine, thank you. Yeah, it's awesome to be here, and I was asked to bring some interesting TypeScript stuff. So I thought about problems I had, and I found one, which is actually has to deal with SuperJSON. So Let me share my screen. SuperJSON, if you haven't heard of it, it's a project that was born from Blitz.js, which is the JavaScript framework. And what SuperJSON does, it serializes JavaScript types to JSON, and it's basically like an extension of JSON, not Stringify. And one of the things that we struggled with a lot is being compatible to pre-ES6. So we want to be compatible with Internet Explorer, and I think like IE6 is the thing that's the problem, I guess. I don't know really, because I haven't had to support IE6 until now, and that's where the problems come from. And the basic problem we had is we used functions like object.values, and that is not available in pre-ES6 JavaScript engines.
So you need to polyfill it, basically.
Yeah, and like the thing is, we built our own wrapper function around it, just now called values of object, and it just like tries if there is values in object available, it will use object.values, and if not, it will fall back. And we can do this because in our tsconfig we say to include all ESNext libraries, and that's why TypeScript allows you to use object.values. If we downgraded that and just said it instead of ESNext, let's just not have ESNext in there, it would, I don't know if it's not live updating, but it would not allow this. And the basic problem that we're facing is we want to have this at a modern setting, because we want TypeScript to actually know that there is object values available. But at the same time, the thing with this here now is that TypeScript will throw, like if you don't disable all these stuff, so I didn't know what I did to disable it, but if you don't disable some settings in TypeScript, it will warn you, because it will say, well, there is always values in object. It won't be missing any time because you have set it to ES next. It will be available. And the basic problem is we can either choose to lower our target to something that's actually IE6 compatible and that's ES5 compatible. And that way we won't be able to use object.values, at least in a really TypeScript compatible way. Or we raise our target up to ES next, and that way TypeScript won't be able to correctly assess our available functions in the target. And that is really the base problem. It's about supporting multiple JavaScript targets. And this is just like a question for all of you. Have you encountered similar problems before? What did you do to solve them? Do you think there's is there some TypeScript feature that I could use for something like this? What are your thoughts on this?
So my naive approach would be to just lower the target, to put it to the minimum I need to support.
Mm-hmm.
Then I'm done.
In theory, it should transpile it to. It should transpile the object.values.
All right, but there may be cases where we don't want to use the transpiled one. So I think with object.values, it's not big of a problem, but there may be new standard functions that are actually implemented natively and that are much more performant, where we want to use the new ones and only use our polyfill version as a fallback.
I don't know how TypeScript, have you checked out how TypeScript is actually polyfilling, like something like object values?
No, it didn't.
Because maybe they are checking for existence of that feature.
That could be.
And then you would be fine.
We could try that, right?
Could try it, right? But I totally get your point. You don't want to unnecessarily polyfill it if it's natively available.
So you say if we lower our target, I think there's like the target to ES3.
You can keep the ES
next.
Yeah,
I think that was a problem, right? We just need to put target to ES3 and then it won't work anymore. I think if we put it to ES6, then it will say reload TypeScript. Huh? That was the one. Then
in
it will
theory,
just say that
it should only warn you if your lib does not have values in object, but the target doesn't affect the warnings.
All right. Yeah. So if we lower the target to ES3 and run npm run build, then we can see that in dist / what was the file, util.js, there, that one, it will values of object, it will not really transpile that one.
No,
because it is available. Maybe because it inferred it. And if we try this and transpile that.
But we had the same problem with flatten or flatmap. Their TypeScript was not successfully transpiling it, although we had target ES5. And then we just used a polyfill for that ourselves. So maybe it's also a TypeScript bug, but from my understanding, if you set the target to lower than where the feature is available, TypeScript should polyfill it for you. So
I think
it might be a bug.
It's kind of a weird problem because with other compilers, you don't have to support multiple target platforms. That's like very much a JavaScript thing.
And I think in Babel you can then say what is it, less than 5% or something, right? It would be interesting. I'm pretty sure there's an issue open at TypeScript somewhere to make this easier. If not, then you should create one. You get my upvote for sure. And so Super JSON, is that running in the browser and Node? How's that? Both.
Yeah,
right?
it's fully. What's the cool word for it? Isomorphic.
Isomorphic. Okay, nice. Yeah, that's definitely, I think, a problem that many library authors are struggling with. Pierre Antoine, in case you're here right now, how are you dealing with that with TypeScript versions? I guess in TS Toolbelt you also require like certain TypeScript versions to be there. Do you just set that in the package JSON, or how do you make sure that people use the right TypeScript version? You are muted, by the way.
I actually use Discord most of the time. Zoom. Okay, so yeah, I let the people do as they wish. The problem is when they do that, they can break stuff. I don't force them to choose a specific version of TypeScript.
Okay, but when you say for TS Toolbelt, you tell your users that they need a minimum version, right? So of TypeScript that they can use it, right?
Yes.
Yeah. We have the same for Prisma client because we recently added some fancy features also with the help of TS Toolbelt, and you need TypeScript 4.1 now, and you get a cryptic error in 3.9. But is there like a standardized mechanism for a package, for example, in its package JSON, to say which minimum TypeScript version it needs?
Yeah, you can use the peer dependency, but a lot of people complain about that.
Yeah, peer dependencies would be an option, maybe. Yeah.
Maybe there should also be like something like an engines field for the TypeScript compiler.
Yeah, exactly, because that's also what we use for Node, the engines field. Yeah. But it seems like the package JSON is the Wild West anyway.
Yeah.
The spec, there are like a few specs around there, and people just add some stuff. Like recently, the React team added the that you can provide where you have the server components and so on. Like if you have a package that can expose the server components part and the client part, they also added that, for example. Anyway, yeah, that's already that was cool. I mean, that's really a problem that I think many people have. So you can also keep us posted if you find the solution for this.
Will.
Awesome. Yeah, I would say we continue with Pierre Antoine. So Pierre Antoine, for the people who don't know him, he is the author of TS Toolbelt, which is one of the most advanced TypeScript libraries out there on the type system level. And he has also helped us a lot in the recent weeks with Prisma, when we made our types a bit more type safe, or sometimes also, yeah, just more better DX. Pierre Antoine, do you have something you want to share with us? You are muted.
It's so bad with the mute button. It's horrible.
Yeah.
Let's go. Share. Does it work?
Yes, we can see your screen.
Okay, so a problem that a lot of users, people usually need to access, how can I say this? Properties that are nested within each other. And actually today in TypeScript it's quite difficult to do this. So someone gave me a challenge to be able to type a get utility to access properties and it's type safe at the same time. I'm just going to put the get utility here. You can take a look at it. So this get utility is quite simple. You give it an object of type O, and you give it a path, and then the get utility returns you the value of the type of that path. So let's go ahead. So let's go prop equals get, and then we have an object, a user object, for instance. And then here you get automatically, you get autocomplete on your object, like on the properties. Like you have a friends property, and then you can look the properties of type user, because friends are users, obviously. And then you can access any kind of, maybe you have 1,000 friends, so let's go look at the last friend you have.
Oh.
Then it tells you, okay, it's a user that can be undefined, but maybe it's not undefined, so we can as well continue. That friend that's sitting at 1,000, you can look at his name, and then it continues working. can even do more friends. And then we'll continue, and so on and so on.
Whoa. This is next level shit.
And the tricky part
Whoa.
of this is that it auto-completes. It doesn't matter how deep you go, it will continue auto-completing your types, and that was not possible before. But with quite a few tricks, I must say I spent maybe 3 days on this. So okay, let's go through this. The actual magic is going through autopath. That's why I named the utility. You give this autopath, you give it the object you're working on. So in this case, it's the user. And the path that you are typing is going to get passed to autopath. And then autopath is going to basically try to go to that path as you type. And when you press that dot, it will give you the next possible path. So if I type something stupid, obviously it can give me anything next, and it's even going to highlight me that it's not a valid path. So let's look at this autopath. I'm not going to retype it because it's so freaking complex. So it's quite simple, actually, the principle. We pass autopath, we give it I call the object, the user object is going to be called A here. We give it the object, we give it the path that we're busy typing, that's going to be called P. And we split that path that we're busy typing. We're going to split it in such a way that we split it on each dot. So when we go back here, we have friends.1000, friends. Then it's going to be split into an array. Actually, that's going to be friends, then 1000, and friends, and 50, and so on. Then thanks to this, we're going to be able to go in each part of the path and access it. So let's look at exec path. Exec path is quite simple. It's what I explained. It uses a path utility. Let's demonstrate it here. It's going to be easier. Type says 0. The path utility is a recursive type that I'll show you just now, where you can give a split path, like I told you, and it will give you the type that's sitting at that path. Or I could give a number as well, yeah, since it's an array. And then we can continue. It does exactly what the autopath does, but the autopath does something extra. It's that it auto-completes you as you type. When you press that dot, it auto-completes. Okay. So when we look at that exec path, it actually gets the next path compared to the path you typed. So if your path is a valid path, this path utility is not going to return you never. And because of that, we'll be able to get the next path, which is encoded in a meta path that I'll show you just now. Let's take the meta path of a user, meta path, user. It's a bit abstract, but the basic principle here is that it takes the object user, and for each property, it will inline the name of the property on the property directly
into a union.
That way, when we access the property, we can get obviously the name of the same property, and we can continue deeper. Let's say if I do metapath user and then I access friends, then the metapath, the next metapath can be accessed like so, and then and so on, and then the name. I don't know if I explained this. It's a bit.
What is the O again? Can you show that?
What?
In line 32, what is this O?
Line 32.
The last. That's just you are just accessing the first element. Sorry.
But basically, what metapath does is it goes all the way through the object, even if it's recursive, inlines the path in such a way that we can dive in it, and it prepares the next path by concatenating the previous path.
We have okay.
So yeah, that's it. It's a bit technical. This part, I don't know what it's so easy. That's it.
We don't hear you anymore. Just
You also had white noise?
You don't hear me anymore?
I don't know who's buzzing.
Yeah, white noise for the general.
Some white noise.
Is it white? I don't know what it could be.
Weird. No, it's better, yeah.
Okay. So yeah, that's it. This is actually the complex part that processes the user and concatenates the paths, replacing the actual properties by the next path. So when you access the property, you get the next path, and you can go deeper and deeper.
So you reconstruct basically the path again.
Yeah.
For the auto-completion on the other hand.
Yeah.
So you do two things. One thing is that you calculate the return type, but also in the input type, you are typing that properly so that the auto-completion works, basically.
Yeah, the return type is calculated by this utility here. That's called path. It's quite simple. You give it an object. That can be any object, actually. I just use the extend inits for documentation purposes. It's not actually useful for anything. And that's the interesting part. I don't know if you guys have used recursive type so far. It's been released recently, but I've been using them for quite a while in the TS toolbar. So the idea of path here is that this type is going to call itself as long as this condition is matched. So the idea here is to try to go to the path that was given. So let's say type is 0, and then we go path. Then we can name string, very simple, and then we put name here. Okay. So what it's gonna do actually, it's gonna receive the object, this one named name string, and it's gonna receive the path that's just going to name. So it's gonna go through this list basically, and that's the condition here. That's the stopping condition. As long as the position of I is different of the length of p, then it will continue calling itself. I don't know if you guys follow. Maybe I should.
Okay. I think important to note is that your extends function in line 18 is basically the true. When it returns true, it's the 1, right? If it returns false, it's 0.
Let's rewrite it so it looks more TypeScript-y. And it's the length of p. So 1, 0.
Yeah. Exactly.
So what it's going to do is that the type is going to call itself, because when the position is not equal to the length of p, then this part returns 0. And when this part returns 0, it calls path again. And when you call path again, it calls this function that goes to the type at that part of the path, which is in this case is name. So we go to at, and we get the type again, and then it will do this again and again. So if you put a stupid type here, path, it will just yield you undefined. Okay, but this is
smart. Yeah, this is clever.
Okay. So yeah.
So is it working because if it's an array, so it returns, like it iterates because it's an array on this type? Or is it just a special syntax for like the array syntax on line, like starting from line 18 to like 22 Because like that, for me, it's like, yeah.
Oh, this array is it's a way for you to give the path you want to access. Like, let's say if you had let's put it again.
No, I was just wondering, like, if it's a special syntax for like the stop, the recursive, or because like for me on line 15, it's in my head, it's like an object. It equals an object, an array of objects, right? The path, basically, that's what it is.
Like this. No, oh, okay. Yeah, maybe I should have.
Yeah, that's a map type.
Okay, so that's the map type. Oh, okay.
Yeah, so you can access the properties basically.
It's just a normal object. It's a regular object. Yeah. We pass it the O object. That's this at the moment. Then we have the list of the path where we want to go to, which contains name. And this is a tool of mine that helps to work with numbers. Like in TypeScript, you can't really do iteration. There's no for loops and all these things. So it's a way to have a counter basically. So what we do first is we create an object. That's the falsy. We're going to create a falsy condition that we're going to just call 0 because 0 is false. And when it's false, it will just call the path again. And with that, it will go to that position, the position of the iterator, which is when you start, it's going to be 0. So it's going to access name. So it's going to go at O, and then here instead, when you just begin, it's going to do name basically automatically. And if it's true, it means that we are done, and we're going to just return the type. And when you add this, it's going to cause the type to unfold until the condition is matched.
Yeah. Okay, now I understand. Yeah, I didn't think it as a map, but now I see it with a map. Cool.
So yeah. Okay, so yeah, that's it. So it's a lot of other types that I could go through. The split types. I don't know if you guys have seen the split types.
Maybe you want to repeat that again. So last time we had as template typed template strings are still new. Last time we had someone from Spotify showing us all the crazy stuff you can do with that, and split was one of them. Maybe you want to just revisit how the split is implemented.
Okay, so this one is a bit different. It doesn't involve iteration numbers and indexes. TypeScript has a new feature that is called template literals. And the amazing thing that they did is that you can use infer inside those template literals. So if you have a type, let's do a test again. So hello 0. And then you can do extends infer. You can say here it's going to be actually a number, and here you're going to say infer infer a, and then you say it's a number again. Then by doing this, you can, let's return a, and let's return never. By doing this, you can just, oops, what mistake did I do? Number, it's supposed to work.
This syntax with a number, I haven't seen that yet. I didn't even know
just try like 0.
Oh yeah, sorry, I'm still on the TypeScript 4.1, but it might be why.
So old.
Let's see. They should have done this. Nope.
Yeah, otherwise the 0 is also.
That's strange because I did this just the other day. Okay, whatever. Anyway, but you can infer parts of the string. So you put your delimiter here. In this case, it can be any kind of delimiter. Previously, it was a dot delimiter. And you can say, infer the first part of the string. and then there's going to be a delimiter, and then I infer the rest of the rest of the string. I'll call that before string, BS, and after string. And then you just continue doing that. So you get the first part of the string, you get the delimiter that you're going to remove, and the rest of the string, and you continue doing that until the string is empty. And that way you pile all these little pieces of string into an array, and you get a split string. So if you take the type out, you can do A, B, and C, and your delimiter is this. Then you get the split string.
Not bad. Can you elaborate why you have this wrapper type in line 16? Why you don't directly call the underscore split one?
Why do I have? Why did I split it like this?
Yeah. Mm-hmm.
It's just for make it easier to read.
Okay.
The TypeScript team have a more elaborate one, but I felt like I wanted to split the steps, and I don't want to repeat this condition at every iteration of the recursive type because it adds overhead.
Okay, nice. Yeah, this is some advanced stuff. It's fairly new, right? Yeah, exactly. And Natalia just wrote this in open mic. So if anyone has questions now to the advanced types, now would be a good time to ask. Okay. You still can ask later if you remember or if something comes to your mind.
I think those so advanced people are scared, maybe.
That could also be. That could also be. I think even the TypeScript compiler is a bit afraid of Pierre Antoine.
The TypeScript team is afraid of me.
Yeah. No, this was really awesome. And again, I highly encourage you to check out TS tool belt. And also an important point here again is that what Pierre Antoine is showing here is really advanced stuff, and you don't necessarily need to do that in your all-day life when you build an application with TypeScript. For the people who are not using TypeScript yet, you don't need to know this stuff. Yeah, so
it's a real waste of time sometimes.
I mean, you are basically on the absolute edge, and it's research, right? And we need to differentiate between library code and application code. I think library authors are rather interested in this stuff. If you want to give people a really, really nice API, then you can hide. That's the beauty of TypeScript. You can hide this complexity in the library, and you can have nice, readable application code with all the auto-completion, etc. But usually, at least in my applications, I don't do a lot of advanced TypeScript. It's fairly simple mostly. Just FYI that people are not scared of this now. This is rather library code usually. Okay, so then we have another little presentation prepared from Emil.
Hello.
Hey.
Share screen. So it's not as advanced, but I hope it will be informative to some people.
Yeah, it doesn't have to be.
So basically, I discovered the type of and the return type, and I just ran with it a bit for GraphQL applications. So the first thing I use it for is data loaders, which basically, like say here, I created a simple to-do application. So you have users, which has a couple of to-do lists, and each to-do list has a couple of to-do items. So usually you want to have data loaders for each of them. So let's say you have like a data loader for users. So that's my typical data loader usage. So with Prisma, basically just indenting error. So you find your many, you just dispatch that into a dictionary and then map the keys again. Pretty classical data loaders. And my issue was that I wanted some kind of object in my context that would be automatically typed for, and then resolves all the data loaders directly. So I created this loader thing, which basically generates all the data loaders for all my modules. We're gonna see like what the function actually does, and then uses the type of data loader, which is a function by itself, this function, and then the return type of that function. So you just extract basically the implicitly generated return type of the function loader, and you can see here that it's fully automatically typed for you, and you don't need to do anything, which is an interesting use case. So if we go into like the user, it basically just calls this function that creates the data loader and then assigns that to an object with potentially other data loaders. So what is interesting, like here, it's a simple idea where you just load your user by the ID. But if you have a to-do list where you have, you can either load the to-do list via its ID or via a parent foreign key. So the user foreign key, for example. Now you have like the main data loader, and then you have like by user, the by user data loaders. And then you can use, usually it's a good idea to prime your object. So if you have a primary key data loader, then you pass it to your children data loaders, and then you inside of it you call prime on the primary. So like they're already loaded in memory if you need to. So that way you can, like, how you're going to use it in your resolvers is, for example, here find list. Here it's already done, but like if we type it again, goes loader, and then you have all your loaders. And then if I just want to use the list one, I do .load, and I just enter an ID. But if I want to do it by user, I created this by user, so you just go by user and you .load, and then you put that. So it's an interesting like idea to like automatically type. So we didn't have to write a lot of code basically, and then we have automatically typed data loaders on every point.
Nice. Can you again repeat or show again the context type?
Yeah. Sorry, I was going a bit fast. So here is just to create the loaders. So basically it goes and calls each functions in each module that is the loaders function in the index. It's a default exported function. And that each of them, they create an object which contains the data loader. If people are not really familiar with data loader, basically batches requests together. So if you do like load, the problem of GraphQL is like you can really, the n+1 problem, which is basically if you have a user and they have a multiple lists, you just want to do one query for all those lists of like to-do lists. And then each to-do list has a multiple items. You want to do one query for all those to-do items. So that way you like data load them into one query to the database. So like if we go in the here, basically you see it like user, it goes fetch one user, then fetch all the to-do list, and then all the to-do items in one go, instead of doing multiple queries to the database.
Exactly. I think this in statement, maybe you can keep the SQL query. I think this in statement is important, right? Because it says user.id in, and then you can provide a list of IDs, right? And then the next level, can you show the GraphQL query actually that you are sending there?
What I'm sending is this query here.
So
you go user, and then you go list. I should have started with that. You go list, and then you go items, and then you can even go back to list because I created a back relationship. And since I primed it with the main data loader, it doesn't do another query here. It just uses the already loaded list since I primed it with the
because it has a per request caching, right?
Yes, it's per request caching basically.
If in the same request you access the same thing again, then it sees, I got that already, so done.
But if you don't prime it in the primary key data loaders, then you're not gonna see that. You're gonna have another request here to the database because like you load it through the user at first here, like you load it through the user to get the list of all the list of the user. But here you're using its primary key. So if you don't prime your main loaders, it's gonna do another query to the database.
So now back to the SQL queries that are generated based on this.
So that generates that query.
Yeah. To be honest, we are not in Advanced SQL Meetup, but still,
No.
it's
No. I was
okay.
mostly wanted to show like how you can use the type of a function, and then the return type of that type of to extract a type.
Yeah.
And then I have like that was my base example, and then for another project.
Before you move on, can you again show the context type, actually, the
Yes.
one that here you have been importing?
Yeah. So basically, what it does here is just loading. That's your context object that you pass around. Like I really like this pattern, even if you're using REST, to have a general context is really interesting, and then you have like all the loaders in there.
And that means when you're now calling this loader function in line 15, you are basically creating a fresh loader context, so to say, fresh loader instance, so that it caches within that context. And we just hope that the JavaScript garbage collector just collects that away once the request is done. That's how JavaScript
we do
works.
hope that, but like that loaders are always scoped to a request anyway. It's never a good idea. Well, in some cases it's a good idea to share.
I think if you don't do the caching, but the batching part, you don't need to put it on a per request basis.
Obviously,
All right, but in your example that you just showed, it's useful to have it with the caching together.
And mostly what I wanted to show is how you're going to use it in your application, which is because like I don't like to type types if they can automatically be generated for me.
It's interesting because what you have here in this in this file that you have open here right now, find list items. The next level would be that we're automatically typing the function, right? Like because
that's
in
coming.
Next.js, in Next.js, that is something I would like to see, because then you could have like the get static props, get server side props automatically typed. It's not yet possible, but there is an issue open for that, where people want a whole module to be able to be typed from outside, or the exports at least of a model.
You have something like that. That's my next like part.
Okay.
Let's close that. So so that was like the simple part, and then for another project, we wanted to have all the functions automatically typed. So say you have like models, and then it's a different architecture, but basically the same thing. So I redid that into a Nexus application, Nexus, which is the same thing, but like it's code first instead of being schema first for people that use that. But the important part is like, say I have my models and I have to do items. So here, what I do is instead of having context, I have this what I call applications, and then that's a function of my application, of my model to do items. So find many, we don't really care what it does, but like basically fetches the data. And what is interesting is each of those models, they have this index which injects a context. So we're using here, like if people want to check it, we're using contravariance. So context, if I go into context is my base context. So it contains like Prisma or Stripe or whatever you want. And then application is a children, if you want, of context, and it contains the return type of models, which itself is typed with all my models and all my function automatically.
And then using the return type off, you don't have to write out of this all the time.
And there's an interesting thing is you don't have app here. Like if we go back to find many and you have app application here, and then when you have it inside the application, you don't have it anymore. Like it's automatically typed, like it will be passed implicitly down there.
What is application here? What is an application for you here?
So application is just another word for context, basically, but it contains, it's because you need to pass context to application. Otherwise you have recursive typing, right? Application needs applications to be.
Okay, this function create application in line 20, where's that called?
That's like the create context you have in.
Okay.
I just call it create application.
Okay.
And the trick is like it only works if you disable one flag in your TS config, which is the strict function types, which prevents you from using contravariance in types, basically.
So do I understand correct? That is basically a little bit like a recursive definition here. Yeah.
Yeah, it is a recursive definition because
Yeah.
basically you need, well, contravariance works that if you have a derived type and a base type, you can pass the base type to the derived type and then it will work. That's contravariance basically.
Yeah.
So here we're passing context, which is the parent, to application, which is the children, and it still doesn't complain because we disabled that flag. So it allows, that's basically what our inject function does here. It takes the context and infers it as an application. You can also just do as application if you want. They don't care about the typing, but I do care about the typing. So if I pass garbage in here, it'll not work basically. And then what is interesting is when you go into here, then you have like you see here, the whole application is available. So you have like models, and then you can go here and then you have like all your models, user, and then you find one and you call it with some input.
Out of curiosity, how do you tell Nexus to type this properly? How does Nexus type the app now properly?
Oh, the Nexus thing is just, well, it's using the application. So right, it's importing the application.
So really say the type is called application, and Nexus basically does static type analysis. I didn't know that Nexus is that advanced. Nice.
Yeah, so basically what it does, like that's Nexus stuff, so I don't want to really get into it, but like they type your context.
So they then import your type, and that way everything is type safe on the context object. That's pretty awesome.
Yeah, they import that here.
If you wouldn't have this, so much manual typing.
So yeah, it's a way to like, it's not perfect, but it's a way to like, and then here, if you need, like usually you would need, like for example, if you have a subscription and you want to like call Stripe, then you would do like app.service.stripe, which is in services here. So you can call from other parts. Like if you have an app object, then you can call all the other methods that are in that app object automatically.
So you basically also have a dependency injection with this, right?
It's a kind of a dependency injection, yeah.
Which is nice. It's a very strong pattern in Nest.js, for example, right? They have the services, and then you can inject what you need, and the same here. That's awesome. So that means you can also obviously easily mock or stop things, right? If you want to.
Yeah. You can also do the same thing. Well, similar thing with classes if you want. Basically, like you can have like a to-do item class, and then you have like inside of the to-do item class you have like define many function. This is just like a functional-ish way to build it, or like building objects that are, because like here you never specify basically the return type. It's always inferred from the injection, and the inject function is just like taking two types, and then basically the function needs to respect the app. It needs to like have this app context and then some kind of input and return something else. It automatically like populate TNU with the function you pass in. That's how it works basically.
Can you again show how you call the inject function?
Yeah, this here. So that's the method.
Context. Okay. That's the actual function implementation.
Yeah, it's actual function implementation. So it does create a lot of objects on every request, but it's not that bad. Like
Okay. So I guess if people wouldn't use Nexus, they could use this pattern also with other GraphQL frameworks, I guess. Type GraphQL and whatnot, they would also allow you to type the context once without having to retype it all the time.
It's just like what I really found is that the type of and then the return type is a really powerful thing that you can do a lot of stuff with. This like a return type, the type of a function and the return type of that type of is pretty interesting.
Can you again show, for example, in the models what you're importing from the models?
Yeah, so that the model is like I didn't show that, but like it's basically just an object which call each of those model basically call the inject function of all of those models and just
Okay.
creates an object of that.
And those, can you show an example how they are implemented? Are those then resolvers for the whole type, or how is that working?
That's like the
Like-
to-do, like we were in to-do list, so that's where you inject
Ah,
your
the one.
stuff.
Okay, that
So
is
that's
then,
the inject part, and then you just combine all of those injections into one bigger object just for simplicity. So if you need to add a new model, you just add it here, and then you go in your index and just add it here, and
Just add the
automatically
key.
everybody can use it. Like you don't need to import anything else in your application anywhere. Basically, you never do basically import anymore. You just go into, you just use app, and then you do stuff with app. Like all your functions are in app basically.
Okay.
It's
and
an
now
interesting different model.
Now a stupid question. Why wouldn't you directly use put like Prisma on the app? Or why do you call
Prisma
it
is
through the
on the app.
models? Ah, okay.
It's just like another, like, it's because if you need to do fancy stuff like subscriptions is not a database type, for example.
Ah,
So
okay.
I just need
So
to like, I need to have like
business
this
logic.
create one.
Ah,
Yeah,
makes sense.
business
If you
logic.
have business logic that you need to attach, that makes
And
sense.
usually I prefer also to wrap all my database call, even if like they have like to do item, I could just do prisma.todo-item.find one, but I
Yeah,
prefer
yeah.
to wrap it into methods, because then I can do access control, or I can do stuff like that. That is not, so for me,
Yeah.
like if you're using the Prisma directly, it's not a really good, like I never use the Prisma directly in my resolvers. I just always pass through the models system, and then yeah.
But I think that's a good pattern. That's what I also meant with Nest. I think they use that a lot, that they would never expose Prisma directly to a controller, but they would always do it via models or services. And that way you have the control that if you want to reuse this logic in different resolvers, maybe in your GraphQL server, then you don't need to, for example, rewrite this line 32 where you do something in Stripe.
Yeah.
It's just always the same thing, basically. So you can reuse that logic no matter from where you use it. That's smart.
Yeah.
That's a
So
nice
those are like
architecture.
full examples, and they are working TypeScript servers. Both of them, they are like code first and schema first. So I put them on GitHub if people want to check them out.
Yes,
and see
that
like
would be
why the
great.
typing works and all that.
That, because I think you have a nice architecture there in your code. I really like that.
Yeah,
How
it's
you,
like
structured everything.
Yeah, it's two different projects. Like I don't really,
Mhm.
it's not really TypeScript related, but like it's a bit
Oh,
TypeScript
that's-
related. It's like either you put it using resolvers or you just go in modules. It's two different architectures.
It's let's say TypeScript in practice.
Yeah. So that's
Yeah.
about what I have.
So someone
People-
just wrote Sébastien Dubois, really interested in having a look at the code. Where will you publish it?
Yeah.
So yeah, exactly. I would also like to have a look at that. Yeah, because after all, what we saw today, I hope, is that TypeScript basically allows everything. Ah, yeah, that's it. Exactly. If you can post that in Zoom, that would be nice. TypeScript basically already today allows you to do kind of everything, but it's on us what we do with TypeScript, right? How we structure our projects, what crazy types we're building. Someone asked earlier regarding Pierre Antoine. I would be more interested in use cases. Pierre Antoine, if you're still there, maybe you want to also elaborate on that. So use cases, I think there we were talking about the split type or these more advanced like typed string literal types. So I think it's still experimental. I can also speak to that question. It's still all experimental, and you probably don't want to use them yet today in production. But people are already, for example, building a GraphQL parser or JSON parser with a string literal. So you could really write down your GraphQL string as it is, and the return type is automatically typed. These kind of things you could now build with that. It's still all not so performant because you are a bit, let's say, abusing the type system there to write a parser. You can write a parser much more efficiently. We were joking last time. I think Simon mentioned it. He can imagine, like, in a few years, the computer science parser classes where young students have to write a C parser in TypeScript. That could happen. Who knows? It's still all early, and I'm not really aware of people yet using that in production, but it's coming. It's coming. At Prisma, we use it a little bit already. The string literals, by the way, for error handling. So for the people who don't know Prisma builds tools around databases, and our main tool is called Prisma Client. Allows you to access data, and it's mainly a TypeScript client. Also, is available in Go. And what you can do, we have a group by feature that we recently introduced, and the types. It turned out the types for a group by are kind of complex. And we had conditions within the argument itself that we wanted to express. And we were, for example, saying that if you want to order by a certain field, let's say that field is called name, then you also have to, if you want to order by that field, then you also have to group by that field. So we needed to be able to express on a type system level to say, it's not in the group by statement. If it's an order by, it also has to be in group by, and to pick out this name of the key. For that, we used the new string literals. I can also share a link about that. I didn't prepare a demo for that now, but we already ship it in the latest Prisma client. You need with that a TypeScript 4.1. Good. I think if the heads are not haven't been smoking yet after Pierre Antoine's demo, then I think they should smoke now, in a good sense. Is there any question? Is there anything anyone wants to ask, as we still have everyone here? If not, that's also fine. There is one last little announcement I want to make. I just posted a link here in Zoom, which is a link to a Udemy course. Someone created an end-to-end React with Prisma course on Udemy. And if you use this link, you get it 100% for free. So it's basically showing you Emil. I would say Emil is already an advanced user. He himself is able to, he sees all the blocks and knows how to put everything together. But sometimes it's useful to just see from beginning to end how everything fits together. And that's really where this course helps with. If you want to use Prisma and React, then this course is the right thing for you. One last link I would like to share, but that is only for Prisma users or anyone who wants to try it out. We are right now in beta for, or in preview for native types at Prisma. So native types basically allow you to access things like bytes or buffers from your database with Prisma Client instead of just, let's say, an int. Native types will go into GA next week. And if anyone still wants to share feedback, now is the right time. Now is the last chance basically to do significant changes. Next week, Tuesday, we will already go in GA with that. Awesome. So then, thanks everyone for coming. It was again a pleasure to learn. My head was for sure bent. I was challenged with some of the stuff that we saw today. I hope some of you could learn something today. And yeah, and again, thanks a lot to Natalia for organizing this.
Thank you.
Awesome. So then I think that's it. Have a nice evening. Have a good time, no matter where you are, in which time zone you are on this planet.
Classic.
Yeah.
Okay, bye-bye.
Bye.
Thanks a lot.